Okay, for the next question, question number 7, definition, again, you can do it yourself. Question number B. They give you two graphs. Both of these are F against, I think this one is expansion. F against L. Okay. Delta L to be exact. So I just read the question there. Okay, the force F against elongation delta L, graph for wire X and wire Y as shown in figure 8.3. The wire have the same original length, same cross-sectional area of 5. Calculate the strain energy when the wire X and wire Y are extended by 1.5 mm. So basically, if you have a graph of F against delta L, and then you want to find the strain energy, it would be just the area under the graph. Okay, if it is a graph of stress against strain, the area under the graph would be strain energy per unit volume. Okay, so this one should be straightforward. 1.5 mm, that means the first graph here would be the area under the graph up until 1.5 here. So it's a triangle. And then the second part is 1.5 is slightly over here. So you can imagine that 1.5 is like 3/4 of 2. So that one will be 3/4 of 253. 3/4 times 250 should get 187.5. So that one is just a ratio. I just use ratio to find the value for F there. So area under the graph would be that one. Number B. 1 for wire X. Again, in exam, to make it easier for pemeriksa to tanda, then I suggest you to write it like this. So it will be U equals to half times with the width and height. So width is 1.5. Don't forget the mm. Make sure you write in SI unit because you want to write down, you want to find U in joule. This would be 300. So 150 times 1.5 that's 1 negative 3 is 0.225. Alright, as 0.23. Okay, question number, okay, the same question, but this time it is for wire Y. Again, you use the same formula, half 1.5. This is 187.5. Is 3/4 from 250. 0.5 excuse me, 1.5 that's negative 3 times 187.5, I should get 0.141. Again, the unit will be in joule as well. Okay, that was for question 1. Question 2. From the graph, calculate the ratio of Young modulus of wire X to the Young modulus to the wire Y. So they want you to find, again, normally if they ask you to write down the ratio, you start straight away from the ratio itself. So Young modulus for X to the Young modulus of Y. So the latter one will be the bottom of the fraction. So basically Young modulus, if you have this graph, Young modulus is the gradient. Obviously you have to calculate the gradient for X. So for X, maybe I can choose the furthest point there. I can choose any point actually, yeah. So let's say I choose that one. It will be 1.5 minus 0 divided by Y over X. So it will be 300 minus 0 over 1.5 minus 0. Okay, now for Y, let's say pick the 750 one. So 750 minus 0 divided by 6 minus 0. So 300 divided by 1.5, 750. Okay, so this one should be like times 10 negative 3 because this is in mm, but I can cancel out that one, so I end up with 1.6. So the ratio of yx over yy will be 1.6. Okay, question number 8. The Young modulus for the seal is greater than that of a brass, which will stretch more easily, which one is stiffer. So the Young modulus determine the stiffness of a material. So the bigger the Young modulus, it is much stiffer, more stiffer. So it says here that the Young modulus for steel is greater than Young modulus for brass. So brass stretch easily will be the brass. Stiffer will be the steel. Okay. So that one's for 8A. 8B, a brass wire 2.5 meter long across section and 1 times its stretch. Okay, calculate the Young modulus. Okay, always try to draw it first. So this one is a wire, so draw it like this. Okay, and then stretch 1 mm, so elongated over here, stretch. So imagine that down here you have a weight that make it stretch. Okay, so the length is 2.5. That one would be your capital L, 2.5 meter L naught. And then cross sectional area A, they give you the A, so 1 times 10 negative 3. And then stretch by 1 mm, that one would be your delta L. I change straight away to SI unit so that you don't get confused afterwards. Load, the mass is 0.4 kilogram. Okay, so calculate the Young modulus Y for the brass. So basically they want you to find Y, which is equals to stress over strain. Stress is F over A, strain is delta L over L naught. Okay, so you have all the values L naught, A, delta L, except F. So force here would be the weight that is pulling the wire downwards. The weight here is equals to mg, so I can write it down as mg L naught, over A delta L. So my Young modulus will be 0.4, 9.81, 2.5, 1 times 10 to the power of negative 3 multiply with 1. Sorry, that one is the delta L. Oh, I mean, it has the same value. Okay, so they give you the area straight away, so you just have to use that one. Sometimes they give you the diameter, so you have to find the area first. In this case, I should get 9.81 times 10 to the power of 6. Okay, so because the strain doesn't have any unit, so you only have the unit comes from the stress, which is Pascal. Young modulus, the unit will be in Pascal as well. Okay, next question, question number 9. Wire has a length of 100 cm, diameter 2 mm, wire X and wire Y. So basically, I want to draw it out like this. That one, let's say, is wire X and this is wire Y. Has a length of 100 cm, 1 meter, diameter I change to R so that easier for me to calculate the area. So 1 times 10 to the power of negative 3. The wire has a length of Y is 2 meter. Diameter R is 2 times 10 negative 3. Force of the same magnitude pull both wire and the extension X and Y produced are 0.1 and 0.04. So this one is delta L, 0.1 times 10 negative 3. This one is delta L, 0.04 times 10 negative 3. So basically, that one is the delta L. Okay, this is L naught. Determine the ratio of the Young modulus for wire X to the wire Y. Again, if it is about ratio, I suggest you to straight away start with the ratio. The latter one would be the denominator of the fraction, the bottom one. So again, this one is stress over strain. Except this one is for X and this one is for Y. And F over A, strain is basically delta L over L naught. Okay, again this one is for X. And same formula you can use down here, except this one is for Y. force is the same, so that one cancel out straight away. So we're left with L0 over A delta L times, maybe I change, this one is fraction, I change to the becomes multiplication, but it will be inverted, A delta L over L0. Okay, but this one you cannot cancel out because this one is for X and that one is for Y. So Yx over Yy, now I want to substitute the values inside. L0 for X is 1. A, this one is a wire, you will expect it to be the cross-sectional area would be circle, so pi r square. This one is 1 times 10 negative 3 square. Delta L, so delta S is equal to 0.1 times 10 negative 3. And multiply with the pi r square over here is 2 times 10 negative 3 square. And then delta L is 0.04 times 10 negative 3 divided by L0 is equals to 2. Okay, pi can cancel out, this one can cancel out, that one cancel out as well. Okay, so basically left with this number here. So I should get 0.8. Okay, so that's it. Continue next question in next video. So I just want to point out this one doesn't have any unit because it is a ratio. Okay, thank you.
She says that she loves